All right, here we go. This is the Unit 5 test. All right, Unit 5 test review. So this one was a lot of identities and pretty much just a lot of formulas. All right, so we had a ton of formulas here. Here they all are. There are 3, 6, 9, 10, 11 different identities that we had for this unit. So yeah, just lots going on. As long as you kind of understand the concepts, then you're just going to plug them into these formulas and we're going to go from there. All right. So like on these first ones, the sum and difference for identities on the unit circle. What I mean about on the unit circle, if you look at 195, that is not one of these values that we've talked about on the unit circle, right? You got the 150s, the 180s, the 30, 60, 90s, 35, 45, all those angles on there. 195 is not one of those angles. So what we need to kind of figure out is let's just find two numbers that are equal to 195 when we add them together, and two numbers being numbers on the unit circle. So for example here, 195, how can we get that? How about 135 plus 60, right? That's 135 plus 60. That gives us 195, right? So instead of thinking of this as the sine of 195, we're going to think of this as the sine of 135 plus 60, right? That's the same thing. Right? And now we have all of these identities. So here brings up our first identity. What is the sine of A plus B here? So I'm just going to write down these identities. I'm not going to do this every time, but we know the sine of angle A plus angle B, right? On this one, I got to keep them all here. The sine of A plus B is the sine of A times your cosine of B, right? And then we have plus the sine of B times the cosine of A, right? So the A's and the B's, those are just going to be the angles, all right? So this first angle, angle A is 135, and then angle B is 60 degrees here. So if we plug all of these in, we're going to have the sine of 135 times the cosine of 60, right? Plus the sine of 60 times the cosine of 135. Right? And the whole reason for this, the whole purpose is the sine of 135, right? This is a value that we can find on the unit circle, right? So you should all, ideally have this memorized. If not, it's not the end of the world. So the sine of 135, that's going to be the second value here. So that's the square root of 2 over 2. So this whole thing is just the square root of 2 over 2, right? The cosine of 60, just go look at your 60-degree angle. The cosine is that first one, that's 1/2. All right, so this is times 1/2, right? Then plus, now we have the sine of 60. The sine of 60, I believe, oops, get out of here. Sine of 60 is square root of 3 over 2. So we have square root of 3 over 2, and then the cosine of 135 is negative square root of 2 over 2. All right. So let's just simplify all of that out here. We have square root of 2 over 4, right? Minus, right? Because we're multiplying a negative here. That's minus square root of 6 over 4. And these are common denominators, so to stick it all on top of a single fraction here. So the square root of 2 minus square root of 6 all over a 4. Okay, that is your sine of 195 here. Let's see here. These are taking up a lot of space. So All right, I'm just going to clear all this out. The next one. All right, so pause the video. If you don't have that written down, pause the video. It's going away. Tangent of 15 now. So the tangent of 15, instead of saying 15, I'm just going to do 45 and 30. How about this? 45 minus 30. All right, here's angle A. Here is angle B. So the difference formula here for the tangent, let's see if I can do this all in one go. That's the tangent of A. So the tangent of 45. You keep the sign the same. So minus the tangent of 30. Right, all over 1 plus. So it's going to be the opposite sign on this one. And then you have the tangent of 45. Times the tangent of 30. All right. So let's go ahead and simplify this. I'm going to go over here because I'm probably going to need some space. Tangent of 45 is 1. The tangent of 30 is square root of 3 over 3. So on the top, you have 1 minus the square root of 3 over 3. And then on the bottom, you have 1 plus 1 times square root of 3 over 3. All right, so that's kind of a mess. So here's what I'm going to do. I'm going to take all of this, and I'm going to get a fresh page because I'm going to need some space. All right. Now, from here, what can we do? I'm going to clean this up just a little bit here. On top, I'm going to call this 3 over 3. I'm going to get a common denominator on top. So you have 3 over 3 minus the square root of 3 over 3. That's just your top fraction. And then on bottom, you have 3 over 3 plus square root of 3 over 3. All right, now from here, common denominators on top and on bottom. So you have 3 minus the square root of 3 all over 3. And then on the bottom, you have 3 plus the square root of 3 over 3. All right, you could multiply by the reciprocal, or you can just recognize that those 3's cancel out. Lots of 3's in this problem. So you have 3 minus radical 3 on top, and then 3 plus radical 3 on bottom, right? So already it looks a lot more simplified, but we can keep going. And what you want to do here is you want to multiply by the conjugate of the denominator, all right? So 3 plus the square root of 3 is on the bottom, so we want to multiply both the top and the bottom by 3 minus the square root of 3. That's what we call a conjugate. Right? And now it's just a matter of double distributing. So 3 times 3, and then 3 times negative square root of 3. So on top, your fraction is going to look like this. 3 times 3 is 9. 3 times negative square root of 3 is negative 3 root 3. Right? Then we need to multiply the negative radical 3 to both things. So that's minus 3 root 3 again, and then plus a normal 3. Right? So that's what the entire top turns into. The bottom, same idea here. So 3 times 3 and 3 times negative square root of 3. So that's 9, right? Minus 3 radical 3, right? And then the same thing here. You're going to have plus 3 square root of 3 minus a normal 3, right? And the whole idea of multiplying by this conjugate thing is because, look, these radicals on the bottom, they cancel out, right? So no more square roots. We rationalized the denominator. That's always kind of our goal here. So this is going to be equal to, on top, you're going to have 12 minus 6 square root of 3 all over 6. Right? And then we can reduce that down to 2 minus square root of 3. All right, so that is our answer, 2 minus square root of 3. So what we did here is you're just slowly trying to clean this up. So if you look at this first one in the top left, right, you have a whole number minus a fraction all over a whole number plus a fraction, right? You want to get common denominators on the top, a single fraction on top and a single fraction on bottom. And then notice how those denominators canceled. And then, you're slowly simplifying it. We had to multiply by the conjugate because we want to rationalize the denominator. You never want that radical in the bottom. So conjugates will get rid of it for us, and then you just simplify from there. All right, so that was the tangent. The tangents are always kind of the worst case scenario ones. We'll do 3 and 4, and then we'll end the video here because this one's getting kind of long. So cosine of -75. What is a -75-degree angle? Let's kind of think about those coterminal things. So the cosine of -75, all right, that is going to be the same thing as the cosine of what? Well, let's just think. Remember when, I think it was in Unit 1, maybe Unit 2, we had these coterminal ideas. So that's a negative angle, so that goes clockwise. So let's try to think of that as a positive one. So I'm just going to do 360 minus 75, and that gives me a coterminal angle. This is the cosine of 285. Right? Now, let's try to find two numbers that add up to 285. So let's go back to our unit circle, and let's just think, how can we get the 285? So that's going to be somewhere over here. If I do 315 and 30, will that do it? That'll do it. All right, so there we go. Yeah, the cosine of 315. Cosine of 315 minus 30. So again, this is angle A, this is angle B. So let's go from there using our cosine identity. We're going to have the cosine. Do I want to write that out? I'm just going to skip straight to it. The cosine of 315 times the cosine of 30. All right, this one we need to be careful because you have to take the conjugate. So you have a minus sign right here. So that means when we expand it out into the identity, it has to be the opposite sign here. And that's going to hold true for your cosine identities here. And then we have the sine of 315 and the sine of 30. So here's what it looks like expanded out. And these are all exact values on your unit circle. All right, so if you just look at your unit circle, just grab all those. The cosine of 315. This is a positive square root of 2 over 2. Cosine of 30 should be square root of 3 over 2. All right. Sine of 315 is negative square root of 2 over 2. And then the sine of 30 is 1/2. Right? So we are just swapping out those sines and those cosines, but they're exact values. Right? So this is going to be equal to square root of 6 over 4 minus the square root of 2 over 4. And putting that all under one fraction, you get square root of 6 minus the square root of 2 all over 4. Right? That's your cosine identity there of -75. And kind of the, I don't want to say secret, but the key on this one was finding a coterminal angle. I mean, you didn't have to do that. That was just the first thing I thought to do. You could probably do like 45 minus 120. That might get you -75. I don't know. I'd have to look that up. But that is definitely an option you can do. And just like on all of these, you don't have to use these exact numbers, right? You might have seen something else, right? Two numbers that add up to 255 on this next one. What I see might be different than the one that you find, right? There are multiple ways to do it, but you should still get those same answers here, right? So with this last one here, 255. I feel like, all right, 255. Let's see what we got here. What two numbers can we add together to give us 255? How about 225 and 30? All right, so there you go. And again, if you saw two different ones, great. Um, I don't know what you might have seen, but there are definitely some other ones. Maybe you saw a difference in there instead. 270 minus 45 might get you there. All right. So expanding this one out, the sine identity here. So again, here's angle A. Here is angle B. Let's go to our identities here. Sine of A plus B is sine of A. So the sine of 225 times the cosine of B. This one, the sine stays the same, but you kind of flip the A and the B and the sine and the cosine here. So then you're going to have the sine 30 times the cosine of 225. Right? So plugging all that in, looking at your unit circle, 225. The sine of 225 is negative square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. Plus the sine of 30 is 1/2. And then the cosine of 225, also negative square root of 2 over 2. Pay attention to which quadrants these values are positive and negative. That's going to come in handy later on when we get to those half angle identities, just kind of a heads up. So this is negative square root of 6 over 4. Then we're going to have plus this is negative square root of 2 over 4. Therefore, we have negative square root of 6 minus square root of 2 all over 4. Right, so there's questions 1 through 4 done. We're going to pause it there. This video is getting a little long. We'll see you guys in the next one. This one, just looking at them, these won't take long. So we'll see you in the next video here.